Hello everyone. First I'll give you the details of the video. First you just get the details, then you decide whether you have to watch this video or not. So in this, the topic I'm going to discuss is NCRT reactions of alkenes. It is very much useful for JEE Main and NEET exams. And what are the advantages? You can complete all NCRT reactions of alkenes in one video. And another one, at the end I'll give table with the list of reagents. Most of the organic questions while solving, you have to identify what is the reagent given, what is the substrate given, what is the function of the reagent. So reagents play very important role in solving organic chemistry questions. So all reactions of NCRT I'll complete in one shot, but it is very clear. It is a revision video. If you are learning alkanes the first time, there will be no use at all. It is only revision video. Revision video, right? First, here we have alkene with hydrogen gas in presence of platinum, palladium, nickel. So this is catalytic hydrogenation. So double bond is getting affected. So the product produced will be ethane. Catalytic hydrogenation, additional point I am giving, it is an example of syn addition and it is also stereospecific reaction. So the second example also the same reaction. So this is the reaction site, catalytic hydrogenation. So CC double bond will become CC single bond. So the product will be propane. So this is very clear again, syn addition. So catalytic hydrogenation, whether it is a double bond or a triple bond, you cannot control the reaction. So partial hydrogenation is not possible, you cannot control. So the product will be alkane with the same number of carbons. Carbon chain is not getting affected, only the pi bonds are getting affected. So the product will be propane. Right, first three questions are related to catalytic hydrogenation. And the next one is the zinc acid, zinc alcohol, zinc HCl, zinc acetic acid. The function of this reagent, it reduces alkyl halide to alkane. So however mechanism part is not given. So simply what you have to do is this chlorine should be replaced with a hydrogen. Length of carbon chain will be same. Same application, this will be CH3, CH3, the product is ethane. Next we have N-propyl chloride. So this is also related to the same reagent, the product will be propane. And the next one is Wurtz reaction, sodium diether. Sodium diether, it causes coupling of alkyl groups. So the product produced will be ethane. Initially the substrate has one carbon, but here you are getting two carbons, so CC bond formation will take place. This is also related to the same thing, sodium diether Wurtz reaction. So this is a C2H5, C2H5. Ethyl bromide in Wurtz reaction, it gives N-butane. Coupling of alkyl groups will take place. So the next reaction is sodium salt with NaOH and CaO. This is soda lime, caustic soda and quicklime. They are in 3:1 ratio generally, but here already we have a sodium salt of carboxylic acid. It causes decarboxylation. Once again, this is not the exact mechanism how to write the products. So the product will be CH4. One carbon atom will be less. Initially there are two carbon atoms. Now we are getting only alkane with one carbon. So one carbon is coming out in the form of CO2. Next one is Kolb's electrolysis reaction. In case of Kolb's electrolysis reaction, so how to identify electric charge you are supplying. So here this is coming out as CO2, this Na plus and here OH minus, that will be converted to NaOH. H plus ions will undergo reduction. So most importantly, coupling of alkyl groups will take place. So that will give you CH3, CH3. Simply whatever the alkyl group you have, that alkyl group should be coupled. And of course, I already told you carbon dioxide is produced at a anode, NaOH in solution at a cathodic surface, hydrogen gas is also produced. So you just to focus on writing this product. RCOONA becomes RR. Alkyl group you take, just a couple alkyl groups. So these are the reactions given under preparations of alkanes. Next one, free radical substitution reactions. So hydrogen will be replaced with chlorine. So here chain initiation, propagation, termination. And the next one, here catalyst is not given, therefore it is a combustion, exothermic reaction. So methane is highly combustible, so this is used as a fuel. You will get carbon dioxide and water. It is an exothermic reaction. So this is iodination reaction. It is a reversible reaction. So that is CH3I plus a HI. So in order to prevent the backward reaction, you are going to destroy this hydroiodic acid. For that you are using oxidizing agent like HiO3 or HNO3. As a result, this Hi will be oxidized to I2, and of course another product, that is water. It is a comproportionation reaction. Since the reaction is reversible, to prevent the backward reaction we are using HiO3. As long as Hi is available, the backward reaction is possible. You are destroying this Hi by oxidizing Hi to I2. For that we need oxidizing agent. Next one, this is also combustion reaction. So 4 carbons are present, therefore it is a 4CO2 plus H2O. Accordingly you can balance the reaction. And incomplete combustion, that will give you carbon black and water. And what is the use of this carbon black once you think? And the next one, catalytic oxidation. In case of copper catalyst, this is oxidized to methyl alcohol. In presence of molybdenum trioxide, this is oxidizing agent and this is a catalyst, and that is converted to aldehyde. In presence of manganese acetate, this is oxidizing agent and this is a catalyst. The product is a carboxylic acid, most important. So here this is alcohol, aldehyde, carboxylic acid. So here these are the catalysts. And the next one, anhydrous AlCl3 HCl, concentrated HCl, it causes isomerization. So N-alkanes are converted to isoalkanes. So here this is N-hexane. N-hexane mainly that is giving isohexane. Isohexane, this is isomeric products, isomerization. Normal alkanes are converted to branched chain alkanes. The next one is used for aromatization. This is dehydrogenation and cyclization. And most importantly, this is C6H14, and that will give you benzene. So here benzene, this is C6H6 plus 4 moles of hydrogen gas. So aromatization, if you take N-heptane, you will get a toluene. If you take N-octane, you will get dimethyl benzene or ethyl benzene. Next one, when it is heated, when alkane is heated with steam in presence of nickel, that gives carbon monoxide and hydrogen gas. This is called water gas, syngas. And most important reaction, dodecane, when it is heated to 973 Kelvin in presence of platinum or palladium or nickel. This is basically pyrolysis reaction. In this pyrolysis reaction, you will get two products. One is pentene and another one is heptane. One is pentene, another one is heptane. Pentene, that is C5H10, heptane, so that is C7H16. Most importantly, heptane, alkane with 7 carbons, alkene with 5 carbons. There is a confusion whether it is heptene pentane or pentene heptane. So the mixture, when it is treated with the aromatization reagent like Cr2O3, V2O5, it is possible. For example, if it is heptene, aromatization is not possible. If it is pentane, aromatization is not possible. Heptane, so aromatization is possible, and the product you are going to get is methyl benzene. And here these are the reactions given, all possibilities, but some possibilities he gave, need not to remember. They will not ask like this because there are many other possibilities. Here also many other possibilities, but major products. And here quickly, the reagents: H2, nickel, platinum, palladium, catalytic hydrogenation. Alkene is converted to alkane, alkyne is converted to alkane. Zinc acid, reduction of alkyl halide to alkane. Decarboxylation, that is soda lime, that is decarboxylation, removal of carbon dioxide. You will be converting carboxylic acid to alkane with one carbon atom less. Sodium diether, that is Wurtz reaction. Rx is converted to RR, coupling. Methyl halide is giving ethane, ethyl halide is giving butane. Electric charge. In case of electric charge, RCOONA is converted to RR. So this is Kolb's electrolysis reaction. Free radical substitution reaction. So alkane is converted to alkyl halide. In presence of copper catalyst, alkane is converted to alcohol. In presence of molybdenum dioxide, alkane is converted to aldehyde. In presence of manganese acetate, alkane is converted to carboxylic acid. If you take potassium permanganate and alkane with tertiary hydrogen, that is converted to tertiary alcohol, but tertiary hydrogen is compulsory. O2 and ignition, that is a combustion, the products will be carbon dioxide and water. Anhydrous AlCl3 and HCl, N-alkane will be converted to isoalkane. Example, N-butane is converted to isobutane. And finally, Cr2O3 or MO2O3 or V2O5 and Al2O3, heat and pressure, it causes aromatization. Here I missed one reaction. We have tertiary hydrogen that will be oxidized. So alkane will be oxidized and you will be getting alcohol. So this is about alkanes reactions, alkanes NCRT reactions. Thank you very much.